Now we're going to look at an example of hypothesis testing when sigma 1 and sigma 2 are unknown. Okay, and we're going to assume that the two standard deviations are not equal. We'll come to the case when they are equal in a little bit. And now let's look at an example where the raw data is given instead of, see, so far all the examples that we've seen, the sample statistics like sample average and standard deviation, sample size, they were all given to us. Okay, what if we have the raw data and we have to develop that information ourselves? Okay, so in this example, we have a random sample of annual starting salaries in thousands for a number of human resource management majors and a number of marketing majors. Now, suppose if we want to test whether the HRM majors make more money as the starting salary compared to marketing managers. We want to test that. So, okay. So how would we set that up? And given the sample information, how will we go about predicting the test? So first thing first, we have to define all the parameters, the populations, and so on. So first population is starting salary of HRM majors, and population 2 is starting salary of MKT or marketing majors. So let's first type that in. Then mu sub 1 would be the average starting salary of HRM majors. Okay. And mu sub 2 will be average starting salary of MKT majors. MKT being marketing. Okay. So now what we want to test is whether HRM majors make more money at the beginning compared to the marketing majors. So that's what should go as our alternative hypothesis. Mu sub 1, that of HRM majors, minus mu sub 2, which is marketing majors. If that difference is greater than 0 is what we want to test, which means the null hypothesis is less than or equal to 0. Now we need to gather the sample information. Okay. For that, let's go and name the columns. That way it will be easier to set up the formulas. So let's do it one by one because they are of different sizes. So highlight the first column and create from selection. Okay, and it comes from top row. So that's HRM column, and do the same for MKT. So now we have the two columns named. So now this is count HRM and average HRM. Then variance is VAR.S. Sample variance is what we want. This is not population variance. Okay. And STDEV.S, that's our standard deviation. Okay. Now we do the same thing for MKT. Count MKT. Average MKT. VAR.S MKT. STDEV.S MKT. Let's format this. remember sigma sub 1 and sigma sub 2 are unknown, so we have to use the T formula for the hypothesis test. Once again, we start with the difference in sample means. Standard error of estimate is square root of, so now S sub 1 squared and S sub 2 squared are available, so we can go straight to that. S sub 1 squared over n sub 1 plus S sub 2 squared over n sub 2. So that will give us the standard error. The hypothesized value for the difference is 0. So T calc is point estimate minus D sub 0 divided by the standard error. So that will give you the T calculated value. And degrees of freedom, remember for these two population, we have to use the function that I have created, df for T. So first sample n sub 1 comma S sub 1, and then second sample n sub 2 comma S sub 2. So that will give us the degrees of freedom. So now we need to finish the test. We can use T-table approach. So in which case we set up the T-table value. We need to look at the alternative hypothesis. We want the right hand side. So we have T dot INV function, and the probability that we need to use is the cumulative probability. So which means we need to go 1 minus alpha. So for that we have to set up the alpha first, and here we are using an alpha value of 5%. So T table value will be T dot INV 1 minus alpha, and degrees of freedom. So if our T table, if the T calc is greater than this, we can reject the null hypothesis, and it is greater than the T table value, so we will reject the null hypothesis. Okay. Now using the p-value, so p-value approach, we use the T dot dist. Okay. Now there are, again we need to look at the alternative hypothesis. We want the right hand side value. So there is a function called T dot dist dot RT, the right hand side. So we now give the T calc value first, and then the degrees of freedom. And this will give us the p value. Convert that into a percentage. And it is a very small number, okay, like that. So since the p-value is less than alpha of 5%, we reject the null hypothesis. Same conclusion as in the case of T-table approach. Now we need to provide an interpretation that we now have sufficient sample evidence to conclude that the average starting salary for HRM majors is indeed greater than that for the marketing majors, and the probability that this conclusion is wrong is the p-value 0.00026, very small probability that our conclusion is going to be wrong.